You are listening to a universe of possibilities. This is Astronomy FM.
Coming up next, an Astronomy.fm original program. It's time for York Universe, a co-production of the Observatory of York University, Toronto, and the Voice of Astronomy. AFM Radio, AFM Radio, AFM Radio, AFM Radio.
Hello and welcome to York Universe, the astronomy and astrophysics program written and presented by the students, faculty, alumni, and friends of York University. I'll be one of your hosts this evening, Quinton, and I'm joined by Sana and Guggen. We are broadcasting live from the Allan Carswell Observatory. Oh, hey, how's it going?
Good. How are you?
We are. I'm doing great. I'm glad to have you guys on the show. It's been a long time since I've spoken to you. How are you guys doing this week?
Pretty well. Enjoying the weather.
Yeah.
Yeah, I know.
Nice.
It's finally warm. Yeah, I'm really enjoying it. We're finally getting some clear skies. We're finally getting some warm weather. It's really, really nice, especially after the winter we've had.
For sure. It'll be nice to get out and observe.
Absolutely. So, for any new viewers listening in, we are broadcasting live from the Allan I. Carswell Observatory located at York University in Toronto, Ontario, Canada. This is Science Night in Canada, where the lineup is all Canadian. So starting with ourselves, York Universe, then we are moving on to Quirks and Quarks, Western Worlds, and Science for the People. York Universe broadcasts every Monday night at 9 p.m. local Toronto time, or Tuesday morning at 1 a.m. Universal time. The York Universe production works in concert with our online public viewing program run by the Observatory team, which runs between the hours of 9 p.m. to 10 p.m. local Toronto time. You can go to www.yorku.ca/science/observatory and follow the links to OPV, online public viewing, to join the chat. Our broadcast is powered by and in partnership with Astronomy.fm, the voice of astronomy. For any questions or comments you have about our past shows, or if you have suggestions for future topics, please send us an email at observe@yorku.ca. You can always connect with us on Twitter with our handle @YorkObservatory, or Instagram with the handle @YorkUObservatory, and Facebook at Allan I. Carswell Obs. All of our programs are free, but if you would like to make a donation, see our website at www.yorku.ca/science/observatory. So currently, I believe it's around 16 degrees here where I am. I'm just a little bit east of Toronto. Still pretty warm night. The sun is just set, I believe, and it looks like it's going to be a clear night. What about for you guys? What's the weather like?
Nice and clear. Finally.
Finally, yeah. I'm looking forward to seeing the stars tonight. What about you, Guggen?
I'm actually right by the telescopes right now, and it's actually looking a little overcast. Not too bad, but enough to give any telescope or binoculars some difficulty. So I hope it clears up soon, because we've got a couple of planets up, a couple of other cool things to see tonight. So I'm hoping to get out after the show's over.
That's the old observatory curse. As soon as somebody's near the telescope, that's when the clouds show up.
Yeah, no, it's my proximity to the telescope for sure. It's always what triggers the onset of clouds.
Yeah.
That story of my life.
Yeah, and just when you're packing up to leave, that triggers clear skies.
Yep, sure does.
I think they are.
So do you guys want to talk?
At least trying to observe tonight.
Go ahead.
If anyone's in the YouTube OPV chat, there should hopefully be some live images coming from the 1 meter at some point.
Let's hope. This is a good opportunity. I hope we're able to take advantage of it.
Mm-hmm.
You guys want to talk about some of the historical events that happened this week?
Yeah, totally.
All right. So this is one that I'm excited about here. May 14th, 1973. So the 50th anniversary of this event was yesterday. And that event is, of course, the launch of Skylab, which is America's first space station. So Skylab was the only space station operated exclusively by the United States. It was launched from the Kennedy Space Center on May 14th, 1973 by a modified Saturn V rocket. The station orbited at an altitude of around 435 kilometers above the surface of the Earth, and it operated there for 24 weeks until February 1974. So this operational period consisted of 3 missions, Skylab 2, 3, and 4, which involved 3 astronauts each. The Skylab 1 mission, if anybody's wondering why we skipped 1, that was just the initial launch of the space station itself, and there was no crew aboard that launch. So during its operational period, the astronauts aboard Skylab carried out numerous experiments on a wide variety of subjects, including biomedical research, solar observations, studies of the weather patterns on Earth, the material properties of metals welded in a microgravity environment, and even a test of the capacity for spiders to spin webs in low gravity. An additional mission, Skylab 5, was considered, but eventually canceled. If this had gone through, this would have boosted Skylab to a higher altitude, allowing it to remain in orbit for longer. So at this point, all of the crewed missions aboard Skylab ceased, but this satellite did remain in space for several more years. Originally, the plan was to boost it into a higher orbit once the space shuttle project was completed, but the space shuttle was not completed until 1981, and this was too late to rescue Skylab, unfortunately. Skylab's orbit eventually decayed, and it re-entered the atmosphere on July 11th, 1979. The station ended up disintegrating 16 kilometers above the Earth, and debris was scattered across the Indian Ocean and a nearly unpopulated area in Western Australia. A few people were able to find some little bits of debris on their property, but as far as I know, nobody was hurt, fortunately. In the 1980s, NASA developed a plan to follow Skylab up with Space Station Freedom, which would have been a permanently crewed American space station. But this idea was scrapped, and NASA instead devoted its resources to participating in the International Space Station program in 1993, which we all know and love. Crazy to think that we could have had a Space Station Freedom. That is such an American sounding space station.
So do some of the like space vehicles now. I'm kind of failing to remember some of them, but I think at one point there was a space shuttle. It was supposed to be named America or something.
That's really on the nose, huh?
Yeah. Some of the names you can just kind of tell are very American.
Yeah, going from America to overseas to America. Or I guess not overseas, but outer space. You're not really changing places much.
Yeah. I think personally it was a positive development that we ended up, for a while anyway, going down more of like an international collaboration route with the International Space Station instead of all like the national space stations. I do wonder if maybe we're starting to turn the other way on that with the newly new space vehicles, maybe with the emergence of the private space companies as well. I imagine it's kind of decentralizing a little bit. But personally, I think it was kind of a nice look into possibly a future for humanity that's that doesn't have all these national borders, and people are able to participate in the pursuit of science in space. That was kind of what the International Space Station always represented to me when I was growing up.
Yeah,
and it's also much easier, to have like a bigger base of funding from multiple nationalities.
Yeah, it's more efficient.
Yeah, it's always I
Sorry,
do
what were you saying, Sarah?
have some kind of international collaboration for really all of those reasons. It also kind of makes it more accessible because some space agencies like the Canadian Space Agency might not have the resources to, launch a space station, but by buying into international collaborations, they can still send astronauts to space and still participate in space research. It's always nice.
Absolutely. All right, Guggen, did you have a story you wanted?
Where, of course, space travel was in this big. There was like the space race and a big rush to have as many missions come out as possible. And this is, of course, one of those missions, which is the Venera program. And the Venera program was a Soviet project comprised of a series of probes designed to research Venus. So prior to the Venera program, no probe had ever successfully entered the Venusian atmosphere, which is not to say they didn't try. There were many missions throughout the early 60s that attempted flybys or atmospheric entry, but were either unable to get airborne or didn't really fulfill their mission goals. And the first few Venera missions were unfortunately no different. Venera 1 and 2, they never left Earth orbit. And then Venera 3 did get to Venus, but it crash landed on the surface. So we didn't get any data. So it really wasn't a success to get there. Venera 4 was really the first probe that was able to gather data from the Venus atmosphere and send it back. It was able to determine that the composition of the Venus atmosphere was primarily carbon dioxide, but it wasn't able to see much else. We didn't know at the time what the surface pressure of Venus was, and the hull of the probe was able to withstand about 25 atmospheres, so 25 times what Earth's pressure would be at sea level. But we still weren't able to gather any data from the surface of Venus. And a following mission, Mariner 5, actually revealed that the surface pressure of Venus is much higher, closer to about 90 times that of Earth's standard atmospheric pressure. So the understanding was that Venera 4 was lost on the surface. So because of this, and because the next Venera missions, Venera 5 and 6, were already in development and about to be launched, they had to do a little quick time change in the game plan, because 5 and 6, which were launched separately in January of 1969, instead of making them landers with the primary goal of observing Venus's surface or gathering data from the surface, they were launched as atmospheric probes instead of landers, with some fortified hull designs, so that they could survive as long as they could in the atmosphere before being destroyed as they get closer to the surface. So Venera 5 arrived at Venus on May 15th, 1969, and Venera 6 followed closely thereafter on May 17th of the same year. And both probes were able to gather data for almost an hour from Venus's atmosphere and confirm Venera 4's observations about the atmospheric conditions. And these included its carbon dioxide composition, as well as the high temperatures and pressures on the Venusian atmosphere. So these were some two early successful missions to Venus that were conducted by the Soviet Union.
Do you know if there have been any more more recent Venus missions? Because I can't really seem to remember any.
Yeah, I believe there were. So, of course, we had more Venera missions that went up to, I believe, Venera 14. And we had another Mariner mission, Mariner 10, which did a flyby of Venus. And we also had one of the Pioneers, or two of the Pioneers actually went to Venus, also atmospheric missions. Venera 14 and Venera 13 were both landers as well. So Venera 13 recorded sound from the Venus atmosphere, and the later Venera missions, I should mention, were in the 70s and the 80s. So they had a lot of time to really hone the design of the probe, make it able to withstand the atmospheric pressure on Venus for at least a short while, so it could transmit some data back before it was destroyed inevitably, because it's just so hot on, like, it's like the floor is lava and all of Venus is the floor. So we didn't really get much. But there were a bunch of missions afterwards that had flybys, not very many landers.
I still think it's really fascinating how the Venera missions were able to gather like images of the surface of Venus that you can go and look at right now. This is completely alien environment, possibly one of the most hostile environments, at least of the inner solar system. And we can still see like what it would, in theory, look like if you were to stand there. It's really cool. I would encourage any listeners to look up some of the images taken from the surface of Venus, because they're really not the kind of images that you could just go out and take.
Oh yeah, and I should correct myself. So Venera 7 was the first one that touched down that landed successfully, because the other ones previously crash landed or were destroyed by the atmospheric pressure prior to landing. And then a couple of other missions ending with Venera 14 were able to touch down and take pictures.
Hmm.
Yeah, I just want to quickly point out while I have the chance that there, if you log on to the OPV chat, there's actually live imaging of Venus from the 1 meter right now. So this turns out to be good timing.
Oh, beautiful.
Perfect. You can always count on the OPV crew.
Yeah. I also think that this, the floor is lava is probably one of the best comments about Venus that I've heard.
The planet is lava.
Yeah.
Yeah. Sana, I noticed you've got one from a little bit further back still. I'm curious to hear about this one.
Yeah. So May 19th, 1925 this time, which was when Nancy Grace Roman was born. So Nancy Grace Roman, I'll get into this a little bit later, but she was one of the NASA administrators all the way back from the very early days of the administration. So a little bit about Nancy Grace Roman is that she'd been interested in astronomy from quite a young age, and she credits this interest in astronomy to her parents. They both kind of encouraged her to get into science, and she in particular pointed out at one point that I read that her mother would take her out observing, pointing out the constellations and showing her the aurora, which really sparked her interest in astronomy. So she later went on to study astronomy and eventually got a PhD in astronomy from the University of Chicago in 1949. Following receiving her PhD, she continued working at the Yerkes Observatory, where after several years, she eventually became an assistant professor there. During this time working at the Yerkes Observatory, she did a lot of very important research. Her primary area of research was looking at naked eye sun-like stars. She did a survey of the night sky looking for any naked eye sun-like stars in the Milky Way galaxy, and ended up discovering that you can classify them based off of their chemical composition and their motion in the Milky Way. She ended up using these classifications to study the structure of the Milky Way, which ended up kind of shedding some light on its past, so its formation and some of its evolution, which ended up being very, very important work in the field and was actually ranked as one of the most influential papers by the Astrophysical Journal, in which she had published that research. Another really fun thing that she was able to do was she took spectra of the star A.G. Draconis and ended up discovering that it is quite a rare star that has a spectrum that changes over time. So the spectrum that she observed of that star was different than the spectrum that other people had observed of that star in the past. This was I think it was a pretty interesting discovery and definitely got her a lot of attention and sort of raised her profile in the astronomical community. But despite that, and all of this amazing work, she realized that she really wasn't going to get tenure working at the Yerkes Observatory, and she was not being paid very well because she was a woman. So she ultimately, in 1955, decided to leave the Yerkes Observatory and went on to work at the Naval Research Laboratory. She stayed working there for about 4 years until 1959, at which point she was offered a job at NASA, which, like I mentioned before, this was the very early days of the agency, and it had actually only formed 6 months prior to that. Before that, it was NACA. I don't entirely remember what the acronym stands for, but I believe the transition from the NACA to NASA put it more into the space-based sector instead of what it was before. But anyways, it was a very new agency, and once she was hired, she became the first female chief of anything at NASA, and also was the very first chief of astronomy in general at the agency. So she did quite a few different things while she was working as the chief of astronomy in NASA. But one of the major things that she did while she was working there is she was responsible for planning satellites and rocket missions to space. And one of these involved planning for the Hubble Space Telescope. She really did a lot of work for the Hubble Space Telescope and really was the person that was responsible for getting it off the ground and getting it launched into space. The idea of having space-based observatories like HST wasn't exactly a new one, but Nancy Grace Roman was the person who really brought it all together. She worked to get different scientists and engineers to come and work together and actually get the project going, and also worked very hard to get it approved by U.S. Congress, which is definitely the kind of go, no-go decision for any mission, is that it has to get funding and approval from U.S. Congress. And if they hadn't gotten that, then Hubble never would have happened. So she really was the person that did a lot of this early stages of planning for Hubble and really was the person that got the project going. So all of this work earned her the title of the Mother of Hubble because she was the reason that Hubble existed. And not only that, but it really established a lot of kind of a program to create space-based observatories, like the Hubble Space Telescope. So a lot of this sort of set the stage for many of the space-based observatories that we have now and that we've had in the past. So, of course, this includes current telescopes like the James Webb Space Telescope, and also coming soon, the Nancy Grace Roman Space Telescope, which was named in her honor. Prior to it being named the Nancy Grace Roman Space Telescope, which was announced on May 20th, 2020, it was called the Wide Field Infrared Survey Telescope. And basically the gist of this telescope is that it has a primary mirror that's the same size as the Hubble Space Telescope. So it can take images at the same resolution as Hubble, but it's an infrared telescope, not optical. And it also has a field of view 100 to 200 times that of the Hubble Space Telescope. So it's going to be able to take so much more data than the Hubble Space Telescope is able to, just because of that field of view, but at the exact same resolution. So it's a very exciting mission. And it's also kind of great that it was named after Nancy Grace Roman, in part because one of the main goals of this telescope is to investigate dark energy. And when asked what her favorite discovery, or what the discovery that she thought was most interesting that came out of the Hubble Space Telescope, she said was the expansion of the universe and discoveries about dark energy. So it is definitely very fitting that this telescope be named after her. And it's really an awesome way, I think, to sort of honor her contributions to astronomy, since the Hubble Space Telescope has done so much for so many different fields. So it's definitely a great way of honoring her contributions to that. But she ended up retiring from NASA in 1979, which was around 10 years or so before the launch of the Hubble Space Telescope. But she did continue to teach and also worked as a consultant on some things at NASA, I believe, until her death in December 2018. But yeah, on May 19th was the anniversary of her birthday.
Wow, what a remarkable story.
Yeah,
it is. I'm glad that even if she didn't continue working at NASA for the launch of the Hubble, she got to see it, because that really was like the culmination of so much of her work.
Mm-hmm. Oh yeah, yeah. I remember reading she passed in 2018, and I know that it's a different observatory, but it would have been great if she had been able to even see the launch of James Webb, because it seems to me like we wouldn't be really where we are in astronomy if it hadn't been for her and a lot of the work that she did to get Hubble going.
Absolutely.
So,
yeah, absolutely.
Yeah.
I can't think of a more fitting person to name like the next generation space telescope after. Mm-hmm. This is fantastic.
Oh yeah, absolutely. Yeah, I know that typically a lot of observatories aren't necessarily named after NASA executives or NASA administration, like the Nancy Grace Roman Space Telescope was, but she definitely it's really great that it was named after her.
Certainly. All right, so we've had some stories. It seems like we've been moving backward in time. We've had a story from the 70s. We've had a story from the 60s. We've had a story from the 20s, and now I've got a story from the aughts, or sorry, the 10s, but rather the 1610s. So we're going back quite far now. May 15th, 1618. So 405 years ago today was when the pioneering astronomer Johannes Kepler was able to confirm his third law of planetary motion. So what are Kepler's laws of planetary motion? So the first law states that the orbits of the planets are ellipses, with the sun located at one of the foci. The foci, or the focal points, are these two special points located within an ellipse, and they have the important property for all the points located on the ellipse. The sum of the distances between the foci and that point are always a constant. It's kind of like a generalization of how a circle is the set of all points that are a certain distance away from a given point, only there's 2 points this time. Kepler's second law states that a line segment connecting a planet to the sun will sweep out a constant area for a given length of time as the planet orbits. So even though the planet, because it's on an elliptical path, even though it moves closer to and farther away from the sun over the course of its orbit, the amount of area swept out by this line segment per unit time does not change. So both of these laws were published by Kepler in 1609, and they represented an improvement on the earlier Copernican model, which treated the planets as orbiting the sun on circular paths that contain smaller circles or epicycles inside them. Now, Kepler's third law states that if you take a planet's orbital period and you square it, this is proportional to the semi-major axis of its elliptical orbit cubed. The semi-major axis is an ellipse's quote-unquote long diameter. It's the distance between the 2 points on the ellipse that are furthest apart, which both foci are going to lie in between. So this creates a relationship between the size of a planet's orbit and the amount of time it takes to complete that orbit. If you scale up the orbit by a factor of 4, the orbit will take 8 times as long for the planet to complete. So in 1621, Kepler was able to show that this law doesn't only apply to the motion of planets around the sun, but also to the Galilean moons of Jupiter. And this was kind of another advance forward in toward the later Newtonian principle of universal gravitation that showed that all of the objects in the universe, not just the sun, not just the planets, but everything with mass, interacts gravitationally with everything else with mass. So it really was a massive step forward, and another important step in advancing the field of astronomy as we know it today.
I think it's always interesting to hear where some of these laws come from, because it's almost something that we kind of take for granted in astronomy, I think, because I remember doing this in first year. So it's always interesting kind of the history behind it.
Certainly. I didn't realize that even as late as Copernicus, they were still talking about epicycles. Because I thought that it was just the Ptolemaic model with, the geocentric model with the Earth at the center, and then all the planets go around the Earth in circles, but, we need to explain retrograde motion, so they add the epicycles on. I didn't realize that the epicycles, even that they survived even past the point where we realized that the planets move around the sun. I didn't know that going into this. I thought that was really interesting.
Oh yeah. Yeah, it's definitely a lot of fun to hear about. The history of astronomy in general is just very cool.
Yeah, absolutely. A lot of surprises.
Yeah.
Oh yeah.
All right.
Like the detailed accounts of the arguments. Oh. Sorry, that was my only add-on. Oh, that was it. I think previously, a few years ago, maybe on York University, it's ages ago now, we covered a pretty insane and long-lived argument between two early astronomers, or groups of astronomers, and it ended in some of them being completely shunned, and of course some were executed for their opinions. So the old-time historians and historical astronomy debates have always been pretty interesting to look back at.
I thought that the debate between Hoyle and Gamow was bad, but nobody died during that, so I guess things have improved.
I'm trying to remember which one it is I'm thinking about, but there were a lot of really passive-aggressive passages in the books that the two parties would write about what their beliefs were, And so one of them would be like, you know, contrary to popular belief by another unnamed group about this theory, you know,
That's
they're
so
wrong.
petty.
It's actually this way. Yeah. And then they get held in contempt of the church. But anyway, yeah.
I have seen one sort of snarky argument, which was a few years ago, this galaxy GNZ11 was detected as the most distant galaxy ever found at the time. And there was a bit of a debate at one point about whether or not it had a flash of a gamma ray burst, or if it was just a satellite that happened to just by coincidence be in that area and look like a gamma ray burst. And if you look online on the ADS, you can find a series of citations of astronomers arguing with each other. And it's just like someone writes a paper that says, you know, it's so unlikely that this is the answer, so it has to be this one. And then have it being kind of snarky back, like, in response to this, this paper, this is what we think. So I don't think that it has improved much past the snarky responses.
Scientists can be petty too. Duncan, I believe that you've got an This Week in History event that it's going to take us a little bit closer to the present, because we've kind of moved quite far back in history now.
Oh yeah, back to the future. So I think Sun and I are both covering events very close in time in 2009. So the next thing I'd like to look back on is the 23rd and final spacewalk that serviced the Hubble Space Telescope. So the Hubble Space Telescope, which we all know and love, needed quite a bit of service over the course of its planned mission duration. Every so often, things aboard the telescope need fixing or replacing, as with any telescope, to keep everything in good working order, which we were able to do considering it was in Earth orbit and the ISS could go fishing, do some catch and release pretty easily, hold on to the Hubble for a few days at a time before releasing it back into Earth's orbit after making some changes. Of course, astronauts aboard the ISS, not the ISS itself. So overall, Hubble was serviced 4 different times, with 23 spacewalks occurring during these 4 different service missions. And the 23rd and final spacewalk was conducted on May 18th, 2009, and was conducted for some standard and final farewell maintenance to the telescope. Astronauts Andrew Feustel and John Grunsfield first changed an older battery pod and then replaced one of the fine guidance sensors aboard the scope. And they actually had completed those first 2 parts of the service mission, which were the designated parts of the mission, pretty quickly and had extra time. So they decided to replace some insulation layers around the telescope, which really benefited the scope along its next few years. The Fine Guidance Sensor, or FGS replacement, was an essential part of this mission, and it allowed the Hubble to maintain an even more precise focus than ever before, allowing it to look deeper into the universe, keep its focus for longer, and take longer exposures. And this was the most technologically advanced version of Hubble that astronomers had ever used before. A previous spacewalk on the same service mission had replaced the other battery on the telescope, so the telescope had 2 all-new batteries going forward for the rest of its lifetime. And in total, the spacewalk took just over 7 hours of extravehicular activity. And the aim was to extend Hubble's lifespan until 2014. That's where they were optimistic that it could last until, with the new changes, which was an additional 5 years after the service mission was conducted. But the Hubble, which is ever the trooper, is still functioning, gathering some great images and data almost 14 years later and showing no signs of stopping.
I'm so proud of the Hubble.
Me too.
Me too. What a like overachieving first child that's out there. You know, like pat on the back.
I think that of all of the disciplines of science, astronomy is the one that makes you the most likely to empathize with inanimate objects. Because like everybody who was mourning when the Mars rover ran out of power, everybody who like expresses dismay whenever we find out about the JWST getting hit by a rock, like we really do kind of see ourselves in these space probes, and it makes sense because we put so much effort and so much work into building these, and they represent kind of like the cutting edge of our capabilities as a species. It makes sense that we kind of project onto them there. It's just kind of funny, I think.
You do not want to know how Sana and I were plotting to steal the 1 meter in 2019 after it was first installed. I hope Paul's not listening to this one, because he knows about all this, because we would say it right in front of him. And we were like, okay, one of us can rent a truck. The other one is going to have to undo the bolts at the bottom. And then we're going to drive this up to some park in the Bruce Peninsula area where it's dark, and then we're just going to observe all night. We had no plans beyond that.
Suggest
we were going to do
one
day.
Park?
You know what? Hey, maybe we'll bring it up there while you're maybe you'll do a residency this summer, and we can all have some observing time on the 1 meter. You know, of course, Killarney does have a telescope, I believe, there. But
you have two, actually.
But is it a 1 meter?
And some smaller handheld.
Yeah. I would take the 1 meter up there, if only it wasn't such a delicate and very large object that I can't really move.
You know, we have another This Week in History thing listed, but since we've come to the topic of Killarney, I guess I might as well plug it now. I wanted to remind our viewers, the Astronomer in Residence program at Killarney Provincial Park is still accepting applications. They're accepting applications for the months of August, September, and October. So this program hosts astronomers in the certified dark sky site of Killarney Provincial Park in Ontario during the summer months. Our astronomers in residence lead in-person astronomy presentations and shows using the Park Observatory. Qualified candidates will reside for free at the park for their tenure and collaborate with the Allan I. Carswell Observatory on outreach and live stream broadcasts. Ability to create and lead large tour experiences, as well as operate the on-site observatories, will be key qualifying factors. If you're interested in applying to do astronomy at this picturesque location, this could be you. Or to see some samples of amazing astrophotography taken by astronomers during last year's tenure, like mine, please go to www.yorku.ca/science/observatory/AIR. So once again, I have done this. I have done this last year. I'm going to do this year in July. It was a fantastic opportunity. If any of you are interested in doing it, I cannot recommend it enough. So keep that link in mind. yorku.ca/science/observatory/AIR.
Yeah, I've seen some of the awesome pictures that people have taken there. It looks like a lot of fun.
Absolutely. Anyway, sorry for that little tangent. Sana, if you want to get us maybe back on the rails.
Okay, yeah, that was the perfect time to mention it, though. So.
Thank you.
Yeah, so for our last This Week in History, I think it's the last one anyways, going back to, actually staying around the same time period as Geoghegan's This Week in History, on May 14th, 2009, which was the launch of two very important space telescopes. They were both missions led by the European Space Agency, which launched on May 14th, 2009 from Europe's spaceport Kourou, French Guiana, aboard the Ariane 5 rocket that has been very busy launching many different space telescopes over time. So the two missions were two distinct satellites that did very different things. They just launched together on the Ariane 5 because that was kind of more efficient than launching them one by one. The first telescope was the Herschel Observatory, which was a 3.5 meter telescope that observed far infrared and submillimeter light. At the time of its launch, it was the largest infrared space telescope to exist at the time, and it was also the first space telescope that had ever observed submillimeter wavelengths. So it was kind of a groundbreaking observatory. It did a whole lot of different things, which included studying bodies in the solar systems, in our solar system, which included planetary atmospheres, comets, and moons. It also observed the formation of planets by observing protoplanetary disks outside of our solar system. It studied star formation, including discovering a new stage of stellar evolution, which were the formation of these interstellar filaments in clouds of gas that would later go on to collapse and form stars. It also studied very distant galaxies, which included the most distant known galaxies at the time, and had a pretty major discovery, which was it detected molecular oxygen in space, being only the second observatory to make that detection at the time. So it definitely did a whole lot of science that reached into many, many different areas in astrophysics. The second satellite that launched was a radio telescope, the Planck radio telescope. And unlike Herschel, Planck did one thing, which was that it observed the cosmic microwave background radiation. So this is radiation that's left over from the Big Bang, and it left kind of its imprint on the universe. This is it kind of permeates the entire universe. It's currently emitting at radio wavelengths. So Planck, being a radio telescope, was basically well suited to make very detailed observations of the CMB radiation. And while it might not necessarily seem like a huge thing to do to just observe the cosmic microwave background radiation, the observations that Planck took have a lot of very important implications in a lot of areas in astronomy. Primarily, it is able to take detailed measurements of cosmological parameters like the age of the universe, the Hubble constant, which is how fast the universe is expanding, and also matter densities. So how much matter in our universe is baryonic matter, or the normal matter that we're made up of, and how much of it is made up of dark energy and how much of it is made up of dark matter. And these are pretty fundamental observations about our universe and are also used in a ton of different areas in astronomy, especially extragalactic research. We definitely use a lot of the measurements from Planck. And I looked it up just out of curiosity, but the last paper published by the Planck telescope collaboration, which was released in 2018, has 10,000 citations, nearly. So this definitely has a very strong and lasting impact on the astronomical community based off of these great all-sky maps that the Planck telescope was able to take of the cosmic microwave background radiation. So both telescopes, unfortunately, now are decommissioned. They were both decommissioned in 2013, actually, and it was because they ran out of coolant, which was needed to keep the observatory at the correct temperature to be able to be sensitive to the kind of light that it needed to observe. So those are two very, very important missions that were launched May 14th, 2009.
Thank you so much, Sana. I mean, talking about satellites that we have kind of imprinted on. I remember I felt a little pang of sadness when you told me that they both were decommissioned the same year.
Yeah, I was sad when I read that too. I gotta say, I think part of this is the fault of the social media campaigns for these telescopes, because I remember for the Mars rover, NASA will write tweets as the rover. Like, I am this today, or I just observed this. Like, come check out this cool thing I just found. So I do think part of it is the fault of NASA or ESA or whoever is.
I've got a parasocial relationship with a robot on another planet.
Yep.
So to anybody just tuning in now, I just want to remind you, you are listening to York Universe. We are broadcasting live from the Allan I. Carswell Observatory, located at York University in Toronto, Ontario, Canada. You can go to our website at www.yorku.ca/science/observatory for our chat, to ask questions, to recommend content for us, or you can visit us on Twitter at YorkU Observatory. Tonight, you're listening to Sana, Guggen, and myself, Quinton. You should swing by our chat room and click on online viewing on the menu bar for OPV. And that is where our chat room is located. It's a live chat. You can, I believe, see live images of the sky right now. Are we still on Venus? Do you know?
Let me just check. I had closed YouTube, but I see somebody.
All right.
I think I saw a mention of Mars in the OPV chat, so it might be. Nope, we are on some archival images right now, but that might just be because they're switching to a different object. So stay tuned.
Makes sense. It's a nice, clear night. So if you join the OPV chat, you'll be able to see some nice, clear images of the sky over York University right now. I also want to mention this Wednesday, during our regularly scheduled Teletube broadcast at 7:30 p.m., we will be following along with a talk hosted by the Royal Astronomical Society of Canada, Toronto Centre. And it's going to be a talk by Connor Hayes. So if you want to tune into our stream of that talk, you can find us at York U Observatory on YouTube.
Oh, actually, sorry, I was clicking on the wrong video for some reason. They are on the Messier 13, the Hercules globular cluster right now. It just looks like they're adjusting.
Oh, that's beautiful.
Yeah, we looked at it through the IP the other night. It was awesome.
So it looks like we've got some good viewing right now. Sana, you actually have a note here about some of the things we can view just after this broadcast, right?
Yeah, so there's quite a few good observing opportunities this week. If you don't want to stay up too late, you can, at around sunset or even a bit before, you can catch Venus and Mars in the western sky. Venus is looking like a beautiful half moon right now, which is definitely fun to observe with even a small telescope or binoculars. If you're willing to get up a little bit early on Wednesday, the 17th, you can also catch an occultation between Jupiter and the moon, where they're coming within about 0.8 degrees of each other. And the moon is going to be in that gorgeous crescent moon phase, so this should definitely be a fun one to observe. And also, if you're in Toronto and are looking for some very easy observing opportunities, this is a great week for ISS passes. There's going to be 3 of them tonight, including 10 minutes after the show ends. There's going to be 2 of them tomorrow, and then 2 of them on Wednesday night. So this is definitely the week to observe the ISS. This is very dependent on your location. The time that they come overhead and the altitude really changes a lot depending on where you are. So make sure to check NASA's Spot the Station or Heavens Above for the exact time and altitudes of these passes.
All right, fantastic. Do you guys want to do news?
Yeah,
let's do it.
I've been dying to do news. All right. So at the end of April, MIT researchers reported that they had observed a tidal disruption event in the infrared spectrum. So a tidal disruption event, also known as a TDE, is a burst of radiation which is emitted from a galaxy as the supermassive black hole at the center of that galaxy rips up a nearby star. So of the 100 or so TDEs that astronomers have been able to observe, the vast majority of them were detected in the X-ray, UV, or optical bands. So this makes the fact that this tidal disruption event, the fact that it was only visible in infrared with no higher frequency signal detected, that makes it already a little bit unusual. The event is also noteworthy because it was the closest TDE we've been able to detect to date. It occurred in the center of the barred spiral galaxy NGC 7392, which is 137 million light years away. So that may sound distant, but in intergalactic terms, it's quite close by, especially when you consider that the next closest TDE we've been able to witness was more than twice as far away. So NGC 7392 is a young star-forming galaxy, which is part of what makes this discovery so interesting. Astronomers have suspected for a long time that tidal disruption events should occur frequently in star-forming galaxies because they're constantly supplying the central black hole with fresh new stars to gobble up. But for some reason, the majority of the TDEs we've detected up until now have come from older, quieter galaxies. But the researchers suspect that this may just be because we haven't been using the right methods to look for these events. Traditional X-ray and optical surveys may only be able to detect TDEs in old galaxies because they have less dust. And this dust tends to block out much of the high-frequency light coming from the core. So if a TDE were to happen in a young galaxy, like it did with NGC 7392, the burst of X-rays and visible light would get absorbed by the cloud of dust, causing it to heat up and emit infrared radiation instead. So continuing to search in the infrared band could reveal many more of these cataclysmic events happening in the cores of young galaxies, giving researchers a more complete picture of how black holes interact with stars inside the galactic nucleus.
Wow.
Yeah, that is.
I know, right? We got to witness the last moments of a star as it was consumed by a black hole. It's crazy.
TDEs are.
And it was 137 million light years away. It was 137 million years ago this happened. I don't know. I just love astronomy.
That is like gotta be one of my favorite facts about astronomy is like, you all. That is like gotta be one of my favorite facts about astronomy is like, you always observe things in the past. It's really cool.
Yeah.
Also,
I think I once read something that described a telescope as like a time machine.
That's true. It
Mhm.
is. It's a really good point.
Yeah.
All right, Guggen, did you want to give a report here?
Yeah, sure. I have a little brief news item for us. So, New Horizons, launched in 2006 with the primary goal of conducting a close flyby of Pluto in 2015, is one of the most exciting recent planetary missions that have been conducted. Where we all remember where we were when we saw Pluto's heart for the first time. New Horizons has imaged an asteroid, Jupiter, as well as several of its moons on its way to Pluto, too. And it's gifted us some of the best images we've ever seen of Pluto. And since its Pluto flyby, its mission has been extended to continue observations on the Kuiper Belt objects and has reached escape velocity needed to escape the solar system. So it'll be in the Kuiper Belt for a little while, and then about 2028, and thereafter it'll be outside of the Kuiper Belt, outside of the solar system. However, the current status of the mission is not as certain as it was before. And the primary reason behind this is because of budget concerns at NASA. So budget concerns are an unfortunate part of scientific discovery. Every scientist is familiar with budget concerns, whether it be in the lab, geological stuff, any type of science, you're going to have budget concerns regarding your research. And keeping a space probe running, doing all the data collection, software changes, etc., are unfortunately not a cheap venture for space agencies. And New Horizons is no different, despite it being a spacecraft in relatively good condition. Usually, the scientific discovery is worth the investment. At least that's my personal opinion. But sometimes the budget side wins. And last year, a new mission extension was proposed for work in the Kuiper Belt, observing some distant objects to glean more about what a rock's life is like in the distant solar system, how Kuiper Belt objects get to be where they are, a couple of other scientific goals. But at a recent Outer Planetary Assessment Group meeting, or OPAG, NASA, it was revealed that has apparently shifted funding for New Horizons from the planetary division to the heliophysics division of its scientific ventures. New Horizons is currently the only probe in the Kuiper Belt, and it will remain there until 2028. So we have at least 5 more years of potential data to be collected. And it's also unlikely that the New Horizons project will search for another Kuiper Belt object to fly by. So it's looking like the funding towards further New Horizons missions or mission extensions will be on the environment in the outer solar system rather than planetary observations on or studies on new or more distant Kuiper Belt objects. And this change from the planetary to the heliophysics division adds some red tape. The proposals are evaluated a little bit differently, and the original goals of New Horizons as a planetary science probe may not be able to be continued to the same efficacy that they were before. And things apparently turned a little heated between Allan Stern, who's the principal investigator of the New Horizons mission, and Kurt Niebuhr, who oversees the flight programs in the Division for Planetary Science. So whether New Horizons will visit another KBO remains up in the air, and this is apparently due to the difficulty in finding a Kuiper Belt object close enough to New Horizons' current trajectory that it would be able to visit without using up all of its fuel. Hopefully, future budgeting decisions don't cut the program short, and because this would be a little premature. The probe is still considered to be in really good shape. It's expected to be functional well into the 2030s, even after it leaves the Kuiper Belt. So it has the promise to give us a lot of good information about the Kuiper Belt as well as beyond. And this decision is considered mostly budgetary rather than based on scientific output, although some at NASA do believe that extending the New Horizons mission in the planetary science division won't really add much value to the current understanding of planetary science. So there's a little back and forth about where budgeting for this mission should go and how long it should continue to observe Kuiper Belt objects.
Bit unfortunate that we're not going to get to see that we're not going to get to observe any more Kuiper Belt objects from New Horizons.
Yeah.
That's a bit of a bummer.
Yeah, we had a good one with Arikoth, and I think the main concern with Allan Stern and the rest of the New Horizons scientific team is that we don't have any other probes out in the Kuiper Belt right now. So, and we aren't going to get any out there for a long time. So the decision to cut the observation short could have impact on the availability for data in the future.
This seems kind of ridiculous almost, because like it's definitely more expensive to launch a new probe.
Right, which I don't know if they have plans to do. That's the problem. So we're just not sure what funding for the planetary division is going to be doing with research in the Kuiper Belt after New Horizons is done. But, you know, we might as well make the most of it while we're there.
Yeah.
But apparently they've kind of shifted towards heliophysics and think that there'll be better scientific output if they switch to that mission. So who knows?
It's a tough decision, but it's, you know, this is a decision you got to make sometimes.
Yeah. If only we had infinite money and could just do everything we want.
Yeah, if
you
only.
Get a space probe. You get a space probe.
Yeah, exactly.
Sana, you want to finish us off?
Yeah. So this is a bit of a different kind of news story, I think, compared to the other ones, but it's something I'm pretty excited about, and I thought would be interesting to talk about. So here we go. Which is that just this past week, the JWST team has announced what the telescope is going to be doing for the next 2023-2024 observing cycles. So what happens once a year for JWST is that astronomers can submit proposals to the team. They all get reviewed, and there's a team of people, the time allocation committee, that reviews all of the observing programs, picks the best ones, and those are the ones that the telescope is actually going to execute and the observations that it's going to take. So these get planned out quite a bit of time in advance, and like I just said, the observations for the next 2023-2024 observing cycle have just been released. I've kind of skimmed through all of the approved programs, and there's a lot of interesting stuff that it's going to be doing. A couple of interesting highlights is that it's going to be observing the TRAPPIST-1 system of exoplanets, which got a lot of attention when it was first discovered because of the Earth-like planets in that system. So it's going to be observing the atmospheres of the inner planets specifically. It's also going to be observing protoplanets and how they form their atmospheres. It'll be observing this exoplanet TOI 1685b, which is what's called a water world, meaning that it has oceans much like the Earth does and like other moons in our solar system do. It'll also be doing a lot of really cool observations of the stuff in our own solar system, including observations of Jupiter and other gas giants, and some of the gas giant moons, including the plumes of water on Enceladus. And very interestingly, we'll be observing volcanoes on Io in collaboration with the Juno probe at Jupiter, which should definitely be fun. In addition to the planetary science that it'll be doing, there's also a lot of observations on extragalactic astronomy. There's going to be a lot of follow-up observations on very distant galaxies, which have caused a bit of I'm not sure what the right word is here, but it's kind of ruffled a few feathers, I guess, based off of some current observations of these galaxies, where they appear to be too big than would be expected based off of our current model of cosmology. So there are going to be a lot of observations of these objects to try and kind of resolve those issues, figure out that actually the galaxies are what we think they are, and kind of characterize the systems to sort of resolve the issue. I don't think it's as big of a problem as some certain news articles have been pointing out, but it's definitely something that needs to be resolved. There's also going to be a lot of searches for some exotic objects and rare objects, including observations of what are called population 3 stars, which are the first generation of stars in our universe. And astronomers do also have a habit of having some interesting names, and a couple acronyms or a couple funny names that I found in these programs. One of them has to be the worst acronym I have ever seen in my life called CHEERIO, the Ice Astrochemistry at the Edge of Star-Forming Cloud, which is, I think, a very terrible, it's a great acronym, but terrible choice of words, I think. But yeah.
All right. Well, I think that takes us up to the end. So thanks for tuning into York Universe, everybody. I've had a great time tonight. Thanks. Clear skies, and have a good night.
Have a good night.
We hope that you've enjoyed this program from AFM Radio, the broadcast service of Astronomy.fm. This program has been released under Creative Commons license. Please contact us for details. You may find more of our AFM original programs on our website. It's really easy to find us. We are Astronomy.fm. You may also find us in the iTunes radio listings near the top of the News Talk section, and also as an iTunes podcast selection. We'd love to hear your comments. Please email us at radio@astronomy.fm. Thanks so much for being part of the voice of astronomy around the world and across the known universe. This is Astronomy.fm Radio.
If you enjoy Astronomy FM radio, please let us know with a small donation. We do rely on your support, and it's true. Every little bit